I'm Adam Simmons, and today we are happy to speak with Dan Brophy from Capella Space. Dan, can you give us a little introduction to yourself and the company?
Sure, Adam. Yeah, I'm Dan Brophy. I handle U.S. government services at Capella. I'm a 30-year veteran in the aerospace industry, worked for large primes, and now I'm working for a new space startup based in San Francisco, California.
Who is Capella Space, and what are you all striving to do?
Yeah, Capella Space is a space data service company providing the most frequent and timely images of the Earth. And we use radar instead of cameras so we can see in all lighting and weather conditions.
Okay. So the vision of the company is to be a radar provider. So what kind of resolution can we be expecting from the satellite constellation?
Well, we're getting ready to launch our first operational satellite we dubbed Sequoia. That'll go up on a Falcon 9 at the end of March. And we expect a resolution better than a half meter. Our license with NOAA only allows us to sell half meter resolution, but to ensure we have a crisp SAR image, we're designing the system to provide like 0.4 resolution to ensure we get that 0.5 meter capability.
And that'll be a big deal because a lot of the other SAR providers out there right now, especially the European providers, don't really provide anything below, you would say, 1 meter, right?
That's correct, Adam. And the other unique capability that Capella is bringing to the market is high persistence. So we're developing a constellation of 36 SAR small sats to provide 1 hour max, 20-minute average revisit time at any place on the globe. So not only a high quality image, but high frequency as well.
And that's your business model. It's not just, once again, not about high resolution. It's also about quick delivery of those systems with a unique architecture, correct?
Right. So there's several pain points out there today with customers. In addition to the, electro-optical can't see through night or can't see through clouds, we address that. But then the other concern is they don't get frequent enough coverage to monitor like patterns of life and really be able to open up applications for commerce and conservation and people's well-being. Think of disaster relief, things like that. They need a more consistent, regular, cadence in terms of the imagery, so they can really put that data to use. And now to take care of other pain points such as low tasking priority, low or slow tasking priority, and data delivery, we also have implemented some new innovative technologies to help with that, such as a geo relay. So we can task our payload from a geo relay in near real time. And then we downlink to Amazon Ground as a Service. They have 12 locations around the globe at all of their data centers. And we'll downlink data directly from the satellite to Amazon Cloud.
And that goes along with your, so one of the press releases you had a few months ago goes along with the new relationship with Inmarsat, correct? And
yeah, exactly. They are our relay provider. So we send command signals up through Inmarsat, and it relays it down to any one of our 36 SAR satellites. It's a very efficient approach to tasking the payload, and cuts down the time that typically takes where you have to wait for a satellite to fly over a particular ground uplink station to send tasking commands.
So I don't want to get too far ahead of ourselves. You have some slides that talk along these topics, correct?
Yeah, let's show everybody what a SAR image looks like. And here's just an example of the kind of imagery we'll be collecting. I should add that these are taken using our SAR payload. However, we demonstrated the payload on an airborne platform as a precursor to our space mission that's coming up, just to check out the hardware and make sure it's all functioning as we planned, and indeed it is. So up in the left corner is just the automated Capella console. We're going to have a very user-friendly interface using application programming interface. Anyone who has access to the internet will be able to send in a task and retrieve data. And the kind of data we'll be providing will be high resolution images, object detection, change detection, a whole myriad of applications that will come in the form of advanced data products and analytics.
Excellent. And once again, being on the aerial platform here, these images represent also the resolution you're hoping to achieve too, right?
Yeah, that's part of the magic of SAR. We can easily simulate what it will look like from space by just adding the noise in. We're sending a radio signal beam down to the Earth that reflects and comes back, and we're able to simulate with very high precision what the images will look like. So these have been adjusted to replicate what it'll look like from our satellite that'll fly at 500 kilometers LEO, even though they were collected from an airborne campaign.
Excellent. So, and I know you touched on this earlier. So the next slide we have here is why SAR. So you talk about some of the capabilities of SAR over EO, but what directly inspired somebody like Capella to stand up and focus on SAR?
Yeah, well, at any time, the Earth is covered in darkness or in clouds. So with the electro-optical systems, they're very limited to really only about a quarter of the Earth at any time that's accessible from an electro-optical system. And with SAR, we don't have that limitation. And then the reason for the persistence is, if you only have a few satellites flying, you get very limited access in terms of the timeliness of when you'll revisit that same site. So by building a constellation of satellites, we're going to be able to see anytime, anywhere, and do it on a very regular, high cadence basis, which opens up all sorts of new markets for satellite imagery.
Now it's fascinating, and I think on the side you mentioned this to me before, but your constellation is going to have the capability to shoot SAR imagery at night too, right?
That's correct. It's not limited by lighting conditions or weather conditions. So those images that we just showed could be taken at night, and they'd look just the same as what they look like in the daytime.
But aside from that SAR imagery is capable of doing that, you actually intend to do that with your constellation, even from in some limited fashion, right?
Absolutely, yeah. We'll be launching 12 orbital rings with 3 satellites each. So that's how we get to 36, with the 12 orbital planes, 3 in each satellite, or 3 in each ring. That will give us global, collection capability anywhere around the world.
Yeah. So, I mean, I'm just trying to express that nighttime capability on top of your high cadence is also a unique differentiator there. You don't see too many of the image providers do that right now. So, if anybody, actually, I'm trying to think who does nighttime collection. So,
yep, that's why that chart I think is so powerful. It shows, at any time, half the Earth is in the dark, and then there's always cloud coverage too that's limiting the ability of typical electro-optical collection systems.
So the next slide here, it actually talks about the constellation itself. So just like you mentioned,
that's a good lead in. And what I think another thing that's important to point out is that we are an X-band system, so it's a 3 centimeter wavelength. It's it allows us to do high resolution, so we can really detect fine details. It has good reflectivity, and that's why we picked the X-band. So the resolution we talked about, we're targeting for 0.4 meters, and in terms of the time from order to delivery, 20 minutes would be like the theoretical maximum, but with that low number, we're able to offer customers with high confidence, getting imagery in their hands within 2 hours.
That's incredible. And of course, you said with the polar orbit, it sounds like you are going to do, you're capable of doing significant amounts of not just polar ice cap monitoring type of thing, but also maritime observation as well.
Oh, maritime, and you just think about some of the natural disasters that are going on, like the forest fires in Australia. Well, there's a lot of smoke and cloud coverage issues there. We'll still be able to detect hot spots. And the one thing we haven't brought up is the other benefit of SAR is you get phase and amplitude history. So that allows you to extract a lot more information than just electro-optical picture, such as properties like material properties, moisture level, very fine changes in movements. All that can get detected with SAR, and it's not available with electro-optical systems.
Roger that. So clarify, aside from hot spots, because I don't imagine the SAR sensor will be able to pick up the fires directly, but the change detection of the actual structures or infrastructure changes that happen because of the wildfires, you'll be able to see that very clearly and cut right through the smoke to see that activity, right?
Exactly. And think of like Puerto Rico, where they're having earthquakes. We'll be able to identify which structures are the most damaged, and how first responders can prioritize which areas to go to first, very quickly. Where right now there's a lot of guesswork and chaos whenever there's a natural disaster. We'll be able to provide a lot of useful information, whether it's a hurricane or fire or earthquake. We'll be able to identify where to send first responders so they can help save lives and help save structures and homes.
Well, you may make an interesting point about the earthquake. Aside from the structures, SAR can be used to monitor massive changes on scale for the entire terrain, right? So you can see displacement of the entire area because of those earthquakes.
Right, and for conservation too. Yeah, you can detect shifts and movements in the shorelines, and again, you can detect moisture levels. So there's so much you can do. You got to really think of SAR as more of a signature, although everybody thinks about the images, but it's really an RF signature that you can start building a database. When you label the SAR data, you can then detect very quickly what it is you're looking at, and then take action.
Absolutely. In this final slide here, you go back on to the real-time tasking rapid delivery here. And this is just a workflow chart of all that working, that process, correct?
Yeah, it's so important. Today, a lot of people complain that, it's very cumbersome to order space imagery, and then they oftentimes get it so late that the real need for it is gone away. So hearing that, we've responded by applying the best technologies available. A lot of that resides in cloud computing, with artificial intelligence and machine learning, and the cloud does both processing and storage. And we put everything into the cloud. We even put our spacecraft operations are cloud-based, but customers can put in a request through any laptop terminal that have the right accesses and privileges to Capella's ground control station. We collect the image, then we downlink it to any of the ground sites. And I mentioned the Amazon. We also use KSAT for the poles. So we have the high latitude, low latitude, and then Amazon's really in the mid latitude. And with those 12 ground stations that are really nicely spread throughout the globe, we directly downlink the data right into the cloud from those Amazon data centers, and it can get to the customers very quickly once it's in the cloud.
I'm personally excited about this rapid delivery platform only because I have real experience ordering imagery from providers that exist right now. And I can tell you from archive imagery standpoint, some of these providers, even just for archive imagery that should already exist and should be a quick delivery, just selecting what I want, can sometimes still take 24 to 48 hours just to get in my inbox. And that's insane. So
Yeah, and you know what frustrates people is they just don't know where they are in the queue, and we let them know every step along the way. We let them know when the order is received, where it is in the tasking queue, and they can actually see, just like you do for package deliveries these days. You'll know exactly where you are in terms of getting your data and how long it's going to take to get to you. So we're going to take a lot of that mystery out of ordering satellite data.
no, excellent. That'll be a great feature to have. And like I said, I look forward to what kind of advantage that brings, not just to bigger businesses interested in purchasing your satellite data, but even because you're making it easier. I'm kind of interested to see how useful your platform can be to maybe even more generic consumers of satellite data who are interested in using it for non-traditional uses. Even well, I say non-traditional. It's becoming more traditional to use it for machine learning practices, or even just insurance companies and financial institutions who are trying to get on board with using satellite imagery as well. And it's been cumbersome in the past.
Oh yeah, we see so many different markets out there, from infrastructure monitoring, because again, we can detect even the finest changes in movements. So think of bridges and dams and monitoring that. Energy and natural resources, another big market for us. Pipeline monitoring, and think of all the conservation applications. And then in engineering and construction to track the development, because again, we're going to be going over on a frequent basis. We'll be able to identify a lot of information that's going to be very helpful for city planners and smart cities in the future. Maritime is a very big one. Maritime and trade, and how the flow is going in and out of ports and straits. And you mentioned insurance and finance. They're clearly a big user. And then the other one that we're surprised with is the agricultural industry is also a very big user as well. And that they've shown great interest.
Awesome. Now, we've talked very positively about your Constellation coming up, and I'm not trying to put a negative spin on it here, but what are the challenges of space and the obstacles in the industry that you've encountered just starting up the company? And these aren't unique to you as a company, but everybody who tries to launch new technologies for space or even imagery in general, right? What challenges do you say that, hey, space is hard, and these are real things that we're overcoming?
Yeah, well, it is a very exciting time in the space industry. There's a lot of commercial, private capital flowing in. The government, you hear about Space Force and all the new developments going on in that side. It's just so much activity. Right now, they've crossed, I think there's some $24 billion, last I read, invested from private capital going into new space startups. I think we've crossed over 500 new space companies across the globe. Now, that includes a lot of different elements, such as launch and ground processing and other areas. But what's happening is there's been a confluence of capabilities. The new launch entrants, low-cost launchers are available. The IT technology, and then small sats have all converged to make entirely new missions possible that weren't practical just a few years ago.
Awesome. Yeah, no, that's thing. I appreciate the insight. So technology is making this much easier going forward, and allowing companies like you to stand up what you're doing right now. And yeah, so
and then combined with the private capital that has shown a great interest in investing in space, which is also a catalyst.
excellent. Now, before we wrap up here, we have a couple conferences coming up, and you plan on attending them, right? Are you going to be at DGI in another week?
Yeah, well, we'll have a strong representation there. I myself won't be there, but Payam, our CEO and founder, and several of our local representatives from that area will be at DGI, and then of course Space Symposium at the end of March, where we hope to raise our glasses and have a toast to a successful Falcon 9 launch, because that's right about the time it will be launching.
Is
And
that
then June, we have to demonstrate, show our collection system and show a real live demonstration of ordering and delivery of SAR data from our first system that'll be up and running and checked out by that time.
Does the launch time overlap with the with Space Symposium at all? So you're going to have a launch party during the symposium?
Oh, well, you know how launch dates go. They have a tendency to move around, but yeah, right now we're targeted for March 29th, and I believe that conference goes on from like the 30th to April 2nd or 3rd. So
okay, so best hope is you have something to announce right before the conference.
Exactly.
Awesome. And then finally in April, we're going to see you at the Big Geoint Symposium, which registration is about to open up for that.
Exactly, and that's where we hope to demonstrate the capability and the delivery system and council, and we'll be up and running for business. We'll be selling data at that point, and it should make for a very exciting few months ahead.
Excellent. Well, I appreciate your time with us, Dan, and talking about Capella Space, your capabilities, and the upcoming launch in March. This is it's going to be amazing to watch your company grow and to see how you're going to change the industry as the first SAR provider in the United States. So
exactly. Well, thank you, Adam, for this opportunity. It was a pleasure talking with you.